In this video we're going to carry out a hypothesis test of population proportion. The best way I can do it is a question, right? And there's a lot of information here, so I'll take it slowly and we'll try to get our head around it. So suppose that it is known that 27% of all Leaving Cert candidates achieved a B3 or better at Leaving Cert higher level nationwide, right? So that's nationwide. %, got a B3 or higher. A researcher wants to compare the achievements in Dublin with the rest of the country. But he doesn't have the results of Dublin. He doesn't know the whole population of Dublin. So he takes a sample. Okay, so it'll be a sample proportion. This is the actual population, though, because we do have the results of the whole nation. Okay, we just don't have Dublin. So sample proportion of Dublin equals, well, 34 out of the 150 got a B3 or higher, and that is 22.7%. Right. I'm going to change these to decimals. Okay, right. So two important figures for us, this and this. Right, now let's see if we can get our head around this. This is very important. So in the nationwide Leaving Cert, we have a normal distribution. Now we can always take it that the population percentage given would be the mean or the center of that normal distribution. Okay, so we're given 27%, so we're saying 27% is the mean. Right. Now we look at this 90 or this 5% level of significance. What we mean by that is we want to see if we can confidently say that the results of the Dublin students are or are not the same as the other kids in general. Right. Whenever you see this 5% level of significance, that really is just the same as the 95% confidence. Okay, so it's the same thing. It's just opposite sides of the same coin. Right. So this is the hard thing to get our head around. Remember, 95% of the data lie within two standard deviations either side of the mean. So there's 1 and there's 2. So that means if this Dublin result was within 2 standard deviations either side of the mean, so anywhere in here, then I could say with 95% confidence that, yeah, the Dublin kids are getting, you know, around the same results as the kids in the rest of the school. However, if this result lies out here, well, it's outside the 95% confidence interval. Okay, so if it's here or here, and if it's outside, well, then I cannot say with 95% confidence that the kids in Dublin are getting the same results as the kids in the rest of the country. Okay, and that's what the 5% level of significance means. Right. So here's what we do. We write down our mean. And our mean can be shown as mu. And our mean is 0.27. Okay, the mean is always the population that we're getting. Okay, so the percentage to do with the population. Right. Next, then we're going to get our standard deviation, which is sigma. Okay, and standard deviation in this question or these questions with relation to hypothesis testing. Their standard deviation is really our standard error. We just call it standard error. And it's just a more precise way of calculating our margin of error. Okay, if you remember, our margin of error was 1 over root n. Well, this is a more, I suppose, just a more precise way of calculating the error. And it's given by this formula, and we should know it. So we have root population 1 minus population over n, which is the sample. Okay, so we can find that easily enough. So the population was 0.27. 1 minus the population is 0.73, and it's all over the population, or the sample, sorry, which is 150. And that will give us 0.0362. Okay, now just pause for a second. Remember I said 2 standard deviations either side of the mean. But remember, we know it's actually 1.96 standard deviations, to be more precise. So that's minus 1 standard deviation and plus 1 standard deviation. So, if this data lies within 2 standard deviations either side of this mean, then I'm happy to say that Dublin, the results, I suppose, are pretty much the same as nationwide. However, if it lies outside, I'm not happy in saying that. Right, so the next thing we do is we change this to a z-score. And how we get our z-score is we have our number, we take away the mean, and we put it all over our standard error, our standard deviation. Right, so our number is 0.227 minus our mean, which is 0.27, all over our standard error, our standard deviation. And that will give us minus 1.188 as our z-score. Right. So remember I said if it was in this area within 2 standard deviations either side of the mean, then I would be happy that the kids in Dublin are achieving the same results as the rest of the kids. Well, all I have to do is look at this number, and I have to see, does that number lie between minus 1.96 and plus 1.96. If it does, then I'm happy that the kids in Dublin are just performing the same as the other kids around the country. If it doesn't, well then I can say no, the kids in Dublin are performing differently. Does this lie between that, or does it fall outside? Okay. It lies inside. Right? So, if it lies inside, then I'm happy that Dublin students' performance is same as nationwide. So that's practically how we do it, right? So let's go start from scratch now, do our null hypothesis, and off we go. So very first thing when we're asked to do this is we state H0, which is the null hypothesis, and we're going to say that population equals 0.27 or 27%. So really what I'm saying here is the null hypothesis is like I'm presuming there's no change, right? Generally the null hypothesis just presumes nothing different, no change, and we usually denote that by H0. H1 then is the alternative hypothesis, and we're saying the population of Dublin is not 0.27%, which would show that there's some difference, which following on from that would show that the Dublin kids are performing differently. Okay, so next we get, well, we have our population nationwide. Which equals 0.27, and remember, see that as the mean. Our p hat then for Dublin, which is sample proportion, which we have to get, which was 0.227, if I'm not mistaken. Was it? Yep, I think. Yep. Okay, we had to get that because we didn't know the actual population for Dublin, and that got over a B. So now we get our standard deviation, our standard error, population, minus the population, all over our sample, which was 0.27, multiply by 0.73, all over n, which was 150, and that will give us 0.0362. Okay, so I change to a z score then, so z equals, well, my number, what we found, 0.227 minus 0.27, all over the standard deviation, our standard error, that, and I get minus 1.188. There's my important number. I see if minus 1.188 lies between minus 1.96 and plus 1.96. If it does, then accept null hypothesis. If it doesn't, so if it lies outside, then reject null hypothesis. Alright, so do I accept or do I reject? Well, this 1.188, sorry, 1.188 lies between these. So if it lies between, I say therefore accept null hypothesis. What that means is the kids in Dublin didn't perform any different to the kids nationwide. Okay, thanks for that. Okay, next I'm going to show you a second method for getting the hypothesis test, okay, of a population proportion. So as we know already, the percentage of people who got a B3 or more nationally was 0.27, and based on then the research of the survey of 150 people, 0.227 or 22.7% of the Dublin people got a B3 or more. Right. This method I like. Right. It ties in with using the confidence interval. So if we look here, we have our confidence interval. This was a way of setting up. Right, and I should really fix this up a bit. Okay, and what that is saying is the real population is our sample proportion plus our standard error of proportion, okay, the bit we could be wrong. And over this side then, the population proportion minus our standard error of proportion, again the bit that we could be wrong. Right, so here's what we do. We have our population, our standard error of proportion. Well, this is the survey we did. Okay, so it's 0.227, and over on this side 0.227. Okay, and then minus. Now we look at our standard error of proportion. We find out what it is. With the standard error of proportion, it'll be the one. Actually, we'll start this. The p will be what we found. Okay, so it'll be our 0.227, and then 1 minus 0.227 all over the survey. So basically we want to see how much this could be wrong. We do that by putting it into this. And then we multiply it by 1.96. And we get 0.067. And likewise we add to this side, so 0.067. And on this side then we have a real population of Dublin is between 0.294, and on this side then we have our 0.227 minus our 0.067, and we get 0.16. Right, just to make that, I'm going to change this into percentages just so it might make a little bit more sense. Okay, what that is saying is, in Dublin we found that from our survey that as a percentage 22.7% of kids got a B3 or more in their test. However, we could be this much wrong. Okay, we got that based on this here. Okay, that converted to a percentage is 6.7%. So we could be 6.7% wrong. This is all based now on the 95% confidence interval. So we add it to one side, we take it away from the other, and we're left with, we are 95% confident that the real figure in Dublin lies somewhere between 16% and 29.4%. So our hypothesis then is, well, H0 is that there's no change, that the kids in Dublin perform same as the kids in the rest of Ireland. So we'll say that P equals 27% or 0.27. And the alternative hypothesis then is that P does not equal 27%, or 0.27. Right. Now let's see. We look at this 27% and we see, is it within this confidence interval? Is 27% within between 16% and 29.4%? Yes, it is. So if it is, we accept H0. Okay, so we accept the null hypothesis. And what are we accepting? Well, we're saying there is no difference, or there shouldn't be any difference between the kids in Dublin and the kids in the rest of Ireland. Okay? Me personally, I prefer this method. That's not saying we don't need to know the method, because later on we'll be dealing with p-values. So we actually do need to know both. Okay? But in general, for the questions I would use this method. Okay? Thanks.